And welcome back to Factorization Academy. In the previous class, we have discussed about roots of a quadratic equation. Now, in today's class, we will be discussing on graphs of a quadratic expression and the location of their roots. So, let us get right into it. Now, let us take the general form of a quadratic expression y equals to ax square plus bx plus c. Now, to find the graph of this expression, we need to first simplify it. That means, like in yesterday's class, we will be making a perfect square. From those, we will be making a graph. Y equals to a times x square plus b by ax plus c by a. That implies y equals to a times x square plus 2 times of b by 2a of x plus b square by 2a whole square minus b by 2a whole square plus c by a. Now this is a perfect square. So we can write it as y equals to a times x plus b by 2a whole square minus b square minus 4ac by 4a square. Now this can be written as y equals to a times of x plus b by 2a whole square minus, we can write b square minus 4ac as d, discriminant of a quadratic equation, d by 4a. That means we get y plus d by 4a equals to a times x plus b by 2a whole square. Now, this equation is in the form of y equals to ax square. Now we know the graph of this equation. It will be in the form of like this, where 1 equals to a. Like this it will be. Now, therefore, the equation of the expression y equals to ax square plus bx plus c will be in the form of same x square graph, but transferred to minus b by 2a comma minus d by 4a. Now, if a is less than 0, then graph will be reversed. Minus b by 2a comma minus d by 4a. Now let's summarize this. Let our quadratic equation be y equals to ax square plus bx plus c, where with d equals to b square minus 4ac. Then, if a is greater than 0, graph of the quadratic equation will be like this, with the minimum point at minus b by 2a comma minus d by 4a. And if a is less than 0, then the graph will be inverted with maximum at point minus b by 2a comma minus d by 4a. Therefore, range of quadratic expression y equals to ax square plus bx plus c will be minus d by 4a to infinity if a is greater than 0, and minus infinity to minus d by 4a if a is less than 0. Now, we got the graph. Now let's look at the roots of the quadratic equation. Location of roots. For this, we need to understand 4 steps. First, we have to find whether a is greater than 0 or a is less than 0. By this, we can determine the either graph is upwards or downwards. Next, we have to find the discriminant value, either discriminant greater than 0 or discriminant less than 0. From this, we will get the roots, either they exist or does not exist. For example, if minus d by 4a is greater than 0 and a is greater than 0, then the graph will be like this. So there will be no roots for the equation, for this equation. Now the third part, we have to find f of 0. From this we will get either both roots are less than 0 or both roots are greater than 0, or one of the root is greater than 0 and one of the root is less than 0. Now let's just take an example. If ax square plus bx plus c equals to 0 has roots alpha and beta such that alpha is greater than 1, greater than beta, sorry, less than 1, less than beta, then which of the following are true? They have given that the quadratic expression as y equals to ax square plus bx plus c with roots alpha comma beta. And they have said that 1 lies between alpha and beta. Therefore, the graph of this quadratic equation will be either one like this or either like this. And also, discriminant can be anywhere, like minus d by 4a comma minus b by 2a. For this one, it can be like this too, 1 beta and alpha. Also like this. Therefore, we can't say about discriminant whether it is greater than 0 or less than 0. So, first option and second option are ruled out. Now, let's go to C and D. They are asking the sign of A times A plus B plus C. Now, here we can write A plus B plus C as f of 1. Therefore, they are asking the sign of A times f of 1. Let us assume if A is less than 0, then the graph will be like this with 1 in middle, beta and alpha. Then f of 1 must be greater than 0. And if A is greater than 0, then the graph will be like this with 1 in middle. Therefore, f of 1 should be less than 0. In both cases, we got A times f of 1 as less than 0. Hence, A times f of 1, that is A times B plus A plus B plus C will be must be less than 0. Hence, the third option is right. Now, let us go to the second question. Let f of 1 be quadratic polynomial such that f of minus 1 plus f of 2 equals to 0. If one of the roots is f of x equals to 0 is 3, then the other root lies in. That means they are given that f of minus 1 equals to minus f of 2 and f of x equals to 0 has root 3. That means f of 3 is 0. Let us take f of x as ax square plus bx plus c. That means we get f of minus 1 plus f of 2 equals to 0. That equals to a minus b plus c plus 2 times 4 times a plus 2 times b plus c equals to 0. That equals to 5a plus b plus 2c equals to 0. Let us take this is as equation number 1. And also we know that f of 3 is 0. That means 9a plus 3b plus c equals to 0. This is as equation number 2. Now eliminate b from these two equations. We get 3 times into 1. 3 times equation 1 minus equation 2. We get 15a minus 9a, 6a plus 6c minus 3 minus c, 5c equals to 0. That means a equals to minus 5 by 6c. From this we got that if a is greater than 0, then c must be less than 0. That means f of 0 must be less than 0. And if a is less than 0, then c must be greater than 0. That means f of 0 must be greater than 0. Therefore, the graph will looks like for a is less than 0, the graph will look like minus 1, 2 and 3. We know that the magnitude of minus 1 and 2 are 3 same, but the signs are different. So the graph will be like this is x and this will be x. Therefore, root lies between minus 1 and 0 for case a is less than 0. And the for case a greater than 0, we get like this minus 1, 2, 3 with uh, f of 0 should be less than 0. Therefore, the graph will look like this. This will be x and this will be x. For this case also we got the other root lies in between minus 1 and 0. Hence, the other root other than 3 root lies between minus 1 and 0. Option A. Third question. If alpha and beta be the roots of the quadratic equation 4x square minus 16x plus c equals to 0, where c belongs to R, such that alpha is between 1 and 2 and beta is between 2 and 3, then the number of integral values of c are. Now, they have given that the quadratic equation is 4x square minus 16x plus c equals to 0, has roots alpha comma beta, such that alpha is between 2 and 1 and beta is between 3 and 2. Also, we know that a is greater than 0. A means the quotient of x square. Therefore, the graph will look like this 1, 2, 3. with 2 here. Therefore, we will get three equations. F of 1 should be greater than 0, f of 2 should be less than 0, and f of 3 should be greater than 0. From equation 1, we will get that 4 times 4 into 1 minus 16 plus c equals to 0. That means c greater than 0. C should be greater than 12. From equation 2, we will get 4 times 2 square minus 16 into 2 plus c should be less than 0. That means 16 minus 32 plus c less than 0. That equals to c should be less than 16. From third equation, we will get that 4 times 3 square minus 16 times 3 plus c should be greater than 0. That equals to 36 minus 48 plus c greater than 0. That implies c should be greater than 12. Therefore, c must be in the range of 12 to 16. And they are asking the integral values of c. Therefore, the integral values of c are 13, 14, 15. 3. Option D. Now let's go into another question. Consider the equation x square plus x plus 1 whole square minus m times m minus 3 into x square plus x plus 1 plus m equals to 0, where m is real. Find the number of positive integral values of m for which equation has two distinct real roots. So they are saying that this equation must have two distinct real roots. So now let us take this x square plus x plus 1 as y. Now we will get the equation as y square minus m minus 3 times of y plus m equals to 0. Now we want that this equation has two distinct real roots. But there is a one problem that y has a range in between not minus infinity and infinity. Y does not has the range minus infinity to infinity. So there exists a limited range. Now we will find the limited range first. X square plus x plus 1. We have to find the range of this equation. We know that if a is greater than 0, the range will be minus d by 4a to infinity. Therefore, d equals to b square minus 4 times ac. That equals to 1 minus 4 minus 3. Therefore, the range will be 3 by 4 to infinity. That means we need two distinct real roots in between 3 by 4 to infinity. Therefore, Now the this equation will be y square minus m minus 3 times y plus m equals to 0 has unique root, because for any range in between 3 by 4 to infinity, we get values solution for two equations, because the graph of y will be like this. Sorry, graph of y will be like this. For any value of y, there are two values of x which satisfies y. So we need a unique value of y which satisfies the equation y square minus m minus 3 into y plus m equals to 0, and m should the value of the unique root should be greater than 3 by 4. Therefore, first case, unique value, that means discriminant equals to 0. M minus 3 whole square minus 4 times m should be equals to 0. That equals to m square plus 9 minus 6m minus 4m equals to 0. That means m square minus 10m plus 9 equals to 0. M square minus 9m minus m plus 9 equals to 0. From here we will get the as m minus 9 into m minus 1 as 0. Therefore, for discriminant equals to 0, there are two roots of m. M be either 9 or 1. M can be either 9 or 1. Now we need the root should be greater than 3 by 4. Therefore, for y square minus m minus 3 times of y plus m equals to 0 has unique root greater than 3 by 4. Let us substitute m equals to 1. Then we will get y square minus 2y plus 1 equals to 0. That means y square plus 2y plus 1 equals to 0. That implies y plus 1 equals to 0. That implies y equals to minus 1. But this is less than 3 by 4. So m equals to 1 does not satisfy the equation. Now let us try m equals to 9. We will get y square minus 9 minus 3 times m plus 1 equals to 0. That implies y square minus 6m plus 9 equals to 0. That implies y square minus 3m plus 9 equals to 0. That implies y minus 3 whole square equals to 0. That means y equals to 3. Clearly this is greater than 3 by 4. So m equals to 9 satisfies the equation. So answer will be 9. And the number of positive integral values of m will be 1. Now let us do another question. Find the value of a for which the equation 2x square minus 2 times of 2a plus 1 of x plus a minus 1 into a 0 has roots alpha comma beta such that alpha is less than a less than beta. So they are saying that the roots of the equation 2x square minus 2a times 2 times 2a plus 1 of x plus a square minus a equals to 0 has roots alpha beta such that a is in between alpha and beta. This we will get two equations. One, f of a should be less than 0 since a is greater than 0. Sorry, 2. Since 2 is greater than 0, the coefficient of x square is greater than 0. So the graph will be like this. Therefore, f of a should be less than 0. And the other one is discriminant should be less than greater than 0 because we have two roots. Therefore, discriminant should be greater than 0. Now let us do the first one. F of a is less than 0. That means f of x equals to 2x square, 2x square minus 2 times 2a plus 1 of x plus a minus 1 into a. Now then f of a will be 2a square minus 2 times of 2a plus 1 into a plus a minus 1 into a should be less than 0. That means 2a square minus 4a square minus 2a plus a square minus a should be less than 0. Therefore, 2a square, 4a square, a square minus a square plus 3a should be greater than 0, less than 0. Mi- Minus a square minus 3a should be less than 0. That means a square plus 3a should be greater than 0. That means a times a plus 3 greater than 0. Therefore, range of a will be minus infinity to minus 3 union 0 to infinity. Now we got range of a from f of a less than 0. Now we will do discriminant greater than 0. F of x equals to x square 2x square minus 2 times of 2a plus 1 of x plus a plus 1 into a minus 1. We need that discriminant of this equation will be should be 0. That means b square 4 times 2a plus 1 whole square minus 4 into a minus 1 into a into 2 should be greater than 0. 4 can cancel out. 4a square plus 1 plus 4a minus 2a square minus 2a plus 2a should be greater than 0. That means 2a square plus 6a plus 1 should be greater than 0. That means we have to find the range, not range, the roots of this equation. Clear the discriminant of this equation equals to 6 square minus 4 into 2 greater than 0. Therefore, there are two roots and the roots will be minus 6 plus or minus root over 6 square minus 8 by 4. That equals to roots will be minus 6 plus root over 36 minus 8, 28 by 4. That implies we get minus 3 plus or minus root 7 by 2. Therefore, the range of the A will be, A belongs to minus infinity to minus 3 minus root 7 by 2 to union minus 3 plus root 7 by 2 to infinity. We got two ranges, one from here and another one here. No, by taking out common from these two, we get as A belongs to minus infinity to minus 3 union 0 to infinity and this equation, this range. We will get A belongs to minus infinity to here which is greater minus 3 minus root 7 by 2 which is less than minus 3, sorry, which is greater than minus 3, minus 3 minus root 9 by 2. That means the first range will be minus 3 and the other one will be minus 3 plus root 7 by 2 is less than 0. Therefore, minus 3 plus root 7 by 2 to infinity. That implies A has the range minus infinity to minus 3 union 3 minus root 7 by minus 3 plus root 7 by 2 to infinity. Sorry. 0 to infinity. A belongs to minus infinity to minus 3 union 0 to infinity. This completes our class. Thank you. And if you have any doubts regarding this class, you can write down in comment section about the doubts and I will clarify it in the next class. If you have any doubts in this class regarding anything, you can post them in the below comment section. If you have any doubts, you can post them in comment section and I will discuss them in next class. Thank you all. Bye bye.